Problem number 8. So we want to go back to that last problem in number 7, and now we're looking for the next positive radian solution to the equation. Well, I can use the same picture. For example, in part A, we gave the answer 3 pi over 2. If I wanted another positive angle landing at that same spot, I just have to rotate around one more time. In other words, if I just add 2 pi to the angle that I had before, I think I would have it. What is 3 pi over 2 plus 2 pi? Well, 2 pi is the same thing as 4 pi over 2. So that's going to give me 7 pi over 2 as the next answer. Similarly, in letter B, I would just have to rotate all the way around plus another pi. So that's going to be 2 pi plus pi would be 3 pi here. Now, part C is a little different because there were 2 different spots on the unit circle that worked. And so I don't have to go all the way around. We found the first one. The next one, the next spot where the A is 0, happens right here, and that's of course 270 degrees, otherwise known as 3 pi over 2. And then number 9 says, let's try this again, but give the simplest negative angle we can find. Well, in part A, it would just be that angle right there, which is negative 90 degrees, or negative pi over 2. Part B, I would just have to rotate this direction, so negative pi. And then part C, the first negative angle spot I would find would be right here. And so again, that would be negative pi over 2. Problem number 10, we want to find the measure of each angle that's been drawn in there. We're giving our answer in degrees. In the first picture, I have this little 19-degree angle here. Well, I know that this entire angle is 180, so if I just subtract 19 from 180, I'll get the angle that I want, and that turns out to be 161 degrees. In the second picture, again, I have this 73. I know that if I rotated all the way around, it would be 360, and so if I just subtract off that 73, I'll have the angle that I want, and that comes out to be 287 degrees. Letter C, I guess there's a few different ways you could do this. You could figure out this little angle and then add it onto 180, or to do it similarly to the rest, I could say, well, I know that going all the way to here is 270 degrees, and then I'm just stopping 64 degrees short. So whatever this calculation is going to be the answer, and that works out to be 206 degrees. Problem 11 is very similar. We're just going to have to use the calculator. Now we're working in radians. I'm given this little thing here. The whole thing here in radians would be pi. So I just need to figure out pi minus that 0.643. Okay, I'm just doing calculations, so the mode doesn't matter. Pi minus 0.643 comes out to be 2.50 rounded to 2 decimal places. And of course I don't have to write RADS, I'm just doing that to remind myself what I have found here. Part B, let's see, we're given the measure of this littler angle. It's negative 1.48 radians. I want the measure of this larger angle here. So how can we figure that out? I guess what I'm thinking is that the negative doesn't really matter that much. If I just think of this more as like a reference angle, then it would measure positive 1.48 radians. I know that it's 2 pi to get all the way around. So if I just take 2 pi and subtract off the 1.48, then we should have what we want. I guess another way I could have thought of it is 2 pi and then plus the negative 1.48. All right, so we'll get that in the calculator, and it looks like we have 4.80 radians. And then let's see, letter C. Now this angle is clearly a negative angle because it's going around clockwise. It would have been negative 2 pi if it had made it all the way around. It's just short of that by 0.235. So I think what I'll do is I'll figure out the measurement first. It would be 2 pi short by 0.235. Now, of course, whatever the answer is to that, I'm going to have to put a negative in front of it because I know I'm rotating around in a negative direction. 2 pi minus 0.235 gives me 6.05 radians. But of course the final answer is negative 6.05 because we're rotating around in that negative direction. If I had wanted to do that in one calculation on the calculator, I could have done negative 2 pi plus the 0.235, and that would give me also negative 6.05. Problem number 12, we want to do some simplifying here. When I look at letter A, of course, the numbers simplify quite easily. And then I think what I might try is switching everything to sine and cosine. So I have sine on the top, and this would make the bottom 2 sine x over cosine x. I could clean this up by multiplying the big numerator and the big denominator by cosine x. These cosine x's will then cancel, giving me sine x cosine x over 2 sine x. Then the sine x's divide out, leaving me with cosine x on the top and 2 on the bottom. I don't have any way to get rid of the fraction there, so this is as good as it gets. Cosine x over 2. Letter B reminds me of a Pythagorean identity. I have a cosecant squared and a cotangent squared. I just need to write down what that identity is. Let's see, it's the one we get from taking the regular Pythagorean identity and dividing everything through by sine squared. So sine squared over sine squared is 1. Normally the next term is cosine squared, but if I divide that by sine squared, I'm going to get cotangent squared. And then normally the last term is a 1, but if I divide that by sine squared, I will get cosecant squared. So there's the identity. I'm looking for cosecant squared minus cotangent squared. Well, that's going to be really easy. I can have that by just moving that term to the other side. And then it'll say cosecant squared minus cotangent squared is simply equal to 1. And that's it. Letter C, there's different approaches we could take. I think what occurs to me, though, is since I only have one term on the bottom, it's pretty easy to distribute that to both pieces. And then each piece cleans up pretty nicely. On the first one, I don't have to keep this a fraction. I can reciprocate that secant x to the top so that it becomes 5 cosine x. And in the second one, something divided by itself is just 1. And so I end up with this simplest form, 5 cosine x plus 1.